In this video, we're looking at group 7 elements, the halogens. Now, it's an important topic because we can get asked about the reactivity trends within the group, which will link into displacement reactions, but also about the general properties of our group 7 elements. Now, our group 7 elements are found on the periodic table, as seen here. And let's start off by looking at their physical properties. All of our elements here have an increasing melting point as we go down the group, and we can see the physical states of those elements, where fluorine and chlorine are gases, bromine is a liquid, and iodine and astatine are solids, and these are all at room temperature. You also are required to know the colours of these specific elements. Fluorine, pale yellow, chlorine is green, bromine is a red-brown colour, iodine is grey, and astatine is black. And lastly, all of our elements in group 7 are actually diatomic. This means they all come in pairs. So if you're ever asked to write the formulas, it would be F2, Cl2, Br2, and so on. And next we'll look at the chemical properties, starting off with the reactions with hydrogen, where hydrogen reacting with a halogen will always make a hydrogen halide. So for example, if we had hydrogen reacting with fluorine, we would make hydrogen fluoride. And again, we're just substituting the halogen here for anything from the group 7 on the periodic table. We also have a general formula reaction for this, where we'll have H2 reacting with halogen 2, making 2H halide, where X can be anything from group 7. And next up are the reactions with metals. And quite similarly, we have a general formula for this too, where a metal and a halogen will always make a metal salt or a metal halide. And in this case, it's a bit more complex because we can have different metals along with the different halogens. So here's our first example. Lithium reacting with fluorine will always make lithium fluoride. And the ending of these compounds are going to be the same as the previous, where we're just switching the ending of the halogen to ide, IDE. And our second example for this, we use a different metal, so magnesium reacting with chlorine is going to make magnesium chloride. In terms of the formula reactions, you can find a video on the channel which will explain to you how to write ionic compound formulas. As a general idea with our group 7 halogens, the reactivity of the group is going to decrease as we go down the group. Let's have a look at why. Starting off, we have the atomic structure of fluorine. With its 9 electrons, 2 go on the first shell and 7 on the next. Similarly with our chlorine, 2, 8, 7. And we can see here as we go down the group from one to another, we are just increasing the number of electron shells by 1, with the number of outer electrons remaining the same. And this links in to our reactivity. So, as we go down the group, the number of electron shells increases, which means the outer electrons are now further from the positive nucleus. And because of this, there'll be weaker forces of attraction between the outer electron and that positive nucleus, resulting in it being harder to attract an electron to complete their shell. This all links in to the decreasing reactivity down the group. And this here is a 3-mark explanation for the description of the reactivity down group 7. Right, let's apply what we've looked at. Here's your first past paper question. Take the next minute to work through these. And if you finish, skip ahead. Otherwise, pause for more time. Let's see how we've done. Here are the answers. Now, in terms of explaining the position of elements on the periodic table, it depends on two things. In this case, the group number will always tell you how many outer shell electrons the atom has. So our halogens in group 7 will all have 7 outer electrons. And then with question 2 here, the reactivity of elements is dependent on the number of outer shell electrons they have. So, because they all have 7 outer electrons, they're going to behave in a similar way in terms of chemical reactions. Okay, here's our next question. Take the next minute to work through this one. Here are the answers to the question. Now, with this one, it's a memorization task, and they'll expect you to recall the colors or the respective halogen that goes along with them. And our final question for this lesson is as follows. Once again, take the next 2 minutes to work through this one, and if you need more time, pause. Otherwise, skip ahead. Let's see how we've done. Now, in order to explain the reactivity of group 7, we need to relate it to the number of electron shells. And because fluorine is above bromine, it has less electron shells. Therefore, stronger forces of attraction because those outer electrons are closer to the nucleus, meaning it's easier for fluorine to attract that last electron it needs to complete its shell. Okay, let's summarize. Now, we need to bear in mind the reactions of our group 7 elements and refer back to the general formulas here to help you with that. The idea that elements get less reactive as we go down the group, and this is due to the changes in the atomic structures that you can see on the right-hand side there. Our next lesson will be on the group 0 elements, the noble gases. Don't forget to like, comment, and subscribe. I'll see you in the next one.